Okay, today we're going to be looking at Unit 2, Lesson 4, which is Introducing Polynomials. You need to understand that polynomials just means an expression. So if I give you 10x plus 7y, that's a polynomial. Okay, it's an expression, there's no equal sign, no solving involved here. Under polynomial, we have three categories. Our first category is a monomial. This suffix mono means one term. An example of a monomial can be 3x squared is a monomial. This is one term. There's no plus or minus sign. You can have 2x minus 10y. Ooh, sorry, that is not a monomial. You can just have 2x. Okay, again, no plus or minus sign here. It's just 2x. If you want to write down in your notes, one term means that there are no plus or minus signs. Okay, I'm not writing that here in the video, but you can write that in your notes. Again, one term means that there is no plus or minus sign. From monomial, you then have your binomial. Bi means two. So here, instead of having one term, we're now going to have two terms. You can have either one plus or one minus sign here. So it doesn't matter which one is there as long as one of them is present. Again, I'm not writing that here in the video. But two terms means that you need one plus or minus sign. So here you have 2x minus 10y. Now this is a binomial because 2x is one term and negative 10y is another term. Okay, so two separate terms that give you one expression. Another example of a binomial, you have 3a squared b plus 10x. Okay, another binomial. 3a squared times b is one term, 10x is another term. Our last one here is a trinomial. Now, the suffix tri means 3. However, in Algebra 1, we kind of use trinomial to represent 3 or more terms, but the technical terminology of the suffix tri just means 3. So here, I'm only going to share one example. With 3 or more terms, they can all be separated by plus signs, they can all be separated by minus signs, or you can have a combination of both. So I can have one plus sign, one minus sign. I can have two plus signs and a minus, or two minuses and a plus. So it really doesn't matter here as long as there are plus and minus signs. Again, only giving one example here. If I give you negative 5xy plus 3a minus 15b, this is a trinomial. Negative 5xy is one term, 3a is another, negative 15b is your last term. Okay, so you have your monomial, binomial, and trinomial. In class, you will never hear me use their technical terms. I always use polynomial for all of them. Okay, because they all fall under polynomial. Our next vocabulary term is finding the degree of a polynomial. When you are finding the degree of a polynomial, all you are doing is adding the exponents of each individual term, and you choose the largest one. If I look at my first example, this is a monomial. So all I'm going to do here is take my exponents. You have this 2. And anytime you have the exponent by itself, there's always an invisible 1 here. So I'm taking that 2 and the invisible 1, and I'm going to add them together. It's going to give me 3. So the degree of this whole polynomial is 3. If I look at my second example, this is a binomial. You need to understand that binomial is made of two terms, like I said above. So you need to separate the two terms first. I don't care about the plus or minus sign with this vocabulary term. Because when you're finding the degree of the polynomial, the plus or minus signs have nothing to do with it. So here you want to separate your terms, and you want to add the exponents for each term. So with this term here, again, we have that invisible 1. So I'm adding 1 plus 8, which is 9. And with my second term, I'm going to add 2 plus 5, which gives me 7. Out of my 2 degrees, the largest one is 9. So the degree for this whole problem is going to be 9. Okay, again, we are choosing the largest degree out of all our terms. So there's 2 terms here. Our largest degree is 9. Our degree is going to be 9. If we look at our last 2 examples, these are trinomials. Separating the terms first, with number 3, you have 5xyz. Then you have 7xy. And then you have 5z to the 5th power. So individually, with each separate term, I'm going to add my exponents. So here we have 2 plus 1 plus 3, which is going to give us 7. Again, that invisible 1. 4 plus 2 here is going to give us 6. And then here we just have 5. There's nothing else to add that to. So if I look at all 3 of the degrees here for my terms, 7 is the largest one. So the degree for this whole problem would be 7. And then our last example, you have 10xy, 17xz, and 20ab. So again, adding those exponents, we have 7 plus 5, which is 12, 8 plus 3, which is 11, and 10 plus 4, which is 14. So out of all 3 of my degrees, 14 is the largest one. So the degree for this whole problem is going to be 14. Our next vocabulary term is called standard form. Standard form is very, very important because you need to know how to rearrange this question so that all the terms are in order from largest degree to smallest degree. So your very first step, and I'm going to write the steps here abbreviated. So your step number 1 is to find the degree for each term. Once you're done finding the degree for each term, your second step is to put it in order from largest to smallest. That's it. Once you're done with those 2 steps, you move on. So here, first step, I'm going to separate my terms so that it's easier to find the degree. This is where your plus and minus signs become important. It's really one of the only times it's going to become important. So you have positive 100xy is one term, negative 72xyz is a second term, and positive 83 is your third term. So just like we've been doing, we're going to add all of our exponents for each term. Then we're going to put it in order. So here we have 1 plus 3, which is 4. Then we have 2 plus 2 plus 1, which is 5. And our last one is 1 plus 2, which is 3. So here, if I want to put this whole problem in order, I'm going to go by what the degrees say. Now, do not just write this as 5 plus 4 plus 3 in standard form. When you write in standard form, you're using the actual terms that the degree is tied to. So SF for short. Our standard form here, our largest degree is here in the middle. So the first term I'm going to write is negative 72x squared y squared times z. Okay, because this is our term with our largest degree. The next term that's going to go after this is positive 100 xy to the power of 3, because that's the next term that has the next degree. And the term with our smallest degree is our positive 83, a times b to the power of 2. Okay, so that's how you would write this in standard form. From largest degree to smallest. Negative 72 xyz had the largest, then 100 xy had the second largest, and our smallest degree was 83. Our last vocabulary term is called a leading coefficient. Now, in order to find the leading coefficient, the polynomial must be in standard form. It's going to be easier. Now, does it necessarily have to be in standard form? When you're finding the leading coefficient, the answer is no. However, it's easier if it's already in standard form. So in class, for some of you, we just found the largest degree and we picked the leading coefficient. But in terms of this video, we are going to put this in standard form first. So you start with standard form. If I'm adding am I finding the degrees? Here we have 2 plus 3, which equals 5. Then we have 1 plus 10 is 11. And here we have 5 plus 4, which is 9. So here, if I write this in standard form, our largest degree is with negative 12 yz to the power of 10. Next, we have positive 30, a to the 5th power times b to the 4th power. And our last one is 15. Okay, it's positive 15, so we're going to use a plus sign. Positive 15x squared w to the 3rd power. So now that it's in order, all we do for leading coefficient is take that leading term, which is negative 12. So our LC here for a leading coefficient is negative 12. And that's it for this one. Okay, so here you want to keep in mind, put it in standard form because it's going to be easier, and you just pick the whole number in the front. Our last example for this section, if you would like to pause the video to go ahead and try this, you can. Okay, but I'm not going to be there with you for you to pause the video. It's just highly recommended. That way you can practice all of these vocabulary terms. So here they want standard form, the leading coefficient, and the degree. So already I'm going to start labeling what's needed. So we need standard form, SF. We need our leading coefficient, which is LC. And then we need the degree. Do you need to answer these in order? No. You'll see that when you start putting this in standard form, you have to find the degree first anyway. So if you want to answer the degree first and then do everything else, that's fine. So here, finding our degrees, we have 1 plus 1, which is 2. 2 plus 7, which is 9. 9 plus 1 is 10. And 1 plus 2 is 3. So already our largest degree, it's going to be 10. So the degree of the whole thing is 10. Putting this in standard form, you have A9 times B, because that's our largest degree. Then our second largest is negative 9x squared y7. Next one is 3, which is tied to negative 15x times b to the second. And our last one is positive 5xy. Now, our leading coefficient, if you do not see a number written here, it is an invisible 1. So the leading coefficient for this whole problem is going to be positive 1. There is one more vocabulary term I want to add on here that you are not going to see, okay, and that I did not go over in this video because it's not a vocabulary term that you really need the definition for. It is called the leading term. Your leading term is the term that has the leading coefficient. So if I look at this whole problem in standard form, Our leading coefficient is 1, and that is tied to this whole term. So the leading term is 1a to the power of 9 times b. Okay, so leading coefficient is the whole number. The leading term is the whole term that leading coefficient is tied to. So 1 is tied to a9 times b, which is the leading term for the whole problem that's written in standard form.